Hi, everybody. Good afternoon. It's really lovely to see so many of you join us this afternoon for session two. Those of you that came along to session one, well done. You get double stamps. So thank you for coming back for this session. If you weren't here for session one, then don't worry. It's available to watch back on the Maths Emporium, and the slides to go with that are there. We looked at two different topics in there, including equations of circles, which was great fun. Today we're going to look at some new topics maybe that don't kind of frequent your teaching palette too often at GCSE, and we're going to talk about domain and range quite quickly. It's a small topic, just a couple of marks, but we'll talk about that briefly, and then we'll go into the topic that's been on everybody's mind and lips since we launched this qualification, and that's linear programming. And hopefully, like I said to our qualification manager just before we joined this call, I'm hoping that we achieve our objective today and make some of you feel a little more comfortable with the idea of teaching linear programming, because I think you'll find that you're pretty much teaching it anyway at GCSE. We just, as per the course, we just take it that little bit further and deeper to allow students to master that concept. So our extended maths certificate, session two, let's take a little dive into domain and range first, and then we'll go on to linear programming. There's the agenda. And so range and domain first. So let's have a look at the brief course overview. So for those of you that are not so familiar with the content, we have split our content into number, algebra, ratio, geometry, and probability. You'll see there are no statistics included because we felt that GCSE statistics does that job. We didn't want to have a repeat or any overlaps in significant content. So also, we decided that algebra was a key focus. We spoke to a lot of teachers and a lot of key stakeholders in the sector. And as a previous A-level maths teacher, I found that algebra was the area that GCSE students really needed to strengthen and master to make them really good A-level candidates when they transition. So you'll see that there's over 50% algebra content in this course. And you can see the topics just highlighted there, really digging into that mastery element of the GCSE content. So if we have a look at domain and range to start with, so the two spec points on the screen at the moment, you've got GCSE at the top. So students at GCSE are required to, where appropriate, interpret just simple expressions as functions with inputs and outputs. I'm going to show you some examples of GCSE. And then at A level, students need to identify the function's features, including asymptotes, domain, and range. They need to interpret the inverse function, composite functions, all of that fun stuff. And there's some special notes on the right there. So for extended maths certificate, this sits in between. So we're asking students in this course to understand those composite functions, inverse functions, and the graphs that go with it. So some notes on the side, we're going to introduce them to real sets, the notation that they're not, that we're just taking them a little bit deeper with advanced notation and being able to identify domains and ranges of functions. Of course, with the composite functions at the higher course, they have those inverse functions and functions of functions. I should get a pound for every time I say function today. So all of that is wrapped up, but we're just going to bring in that notation ahead of the A-level content. So let's have a look. I think you'll be surprised. I was definitely surprised as to where I found some content in the GCSE course to kind of springboard from. I'll come back to linear programming in a second. So domain and range. The closest I could find in terms of inputs and outputs to really kind of go back to the basics is in the foundation course. And if you use the textbook, I used 9.2 in the textbook that you can see here. And it's that basic idea of getting students to map inputs, adhere to a function, and then work with their outputs. So of course, then, and taking that further in the foundation course, then being able to plot those inputs and outputs as functions. And so, you know, everything kind of makes sense, and they can see the holistic picture as to what's happening. I think sometimes you get that magic light bulb moment from students when they realise that the input and output can be interpreted as coordinates, and then they can plot their graphs. So let's keep the domain and the range quite simple here when we're introducing it to our students. We're dealing with functions. We put something in and it churns something out. So we'll be used to delivering this in terms of, or assessing this in terms of tables of functions, plotting the graphs. I found some nice interesting ones of previous questions that we've seen. So we've got y equals a half x minus 1, so table of values, and plotting. So a nice 5-mark question there. And then another question, y equals 6 over x. So introducing exponentials, inverses, all nice, interesting ones, and using decimals as well. So when we look at the EMC content, the key points that you need to make sure that students are not overwhelming themselves with, especially when we're introducing new keywords, but explaining to them that the domain is the set of the input values. It's just a name that we use for the input values that will map out into the range. So a nice diagram, I think you could use, if I go back a slide, you could use something like this from the textbook and relabel with domains and ranges, so they start to get used to that, those new keywords. Of course, there are some lovely, I've shared some links on these slides that you can access later on. All the links are embedded into those slides. But there's a lot of YouTube videos out there, or other teacher revision platforms that you can use, where they show about one-to-one relations and one-to-many, many-to-one, for example. So students can really play around with those. There might be some sorting activities that they can do, but introducing that idea of relations. So obviously for a function, each input maps to only one output. You've got one-to-one relations and many-to-one relations, which are the functions, but one-to-many relations are not functions. And I think getting students to just play around with that idea, they'll see quite clearly that the one-to-many relation is, you know, they're not functions. So nice keywords, get them integrated, get them hands-on, drawing out little mappings, I think will help cement those new keywords. So we talked about elevating that notation. So we'll give them the Z and the R. So Z is the set of all integers, such as, R is the set of real numbers, making sure that they now start to understand that real numbers include integers, rational numbers, and irrational numbers. That's a really lovely introduction into set notation. And then we go into the EMC textbook. So this, of course, is available. There's a link. If you click on the image of the textbook, it will take you straight to the page where you can have a look. There's sample chapters on the Extended Maths website, so you can have a look in there. I think it's now available on Amazon, and you can obviously order it direct through us. So the please as well do share thoughts. We'll share contact details on the slides towards the end, but do share your thoughts with the textbook. It's one of my favorites. It sits on my desk every day, so I hope you're enjoying it as much as I am. But let's have a look at where we take that then from GCSE, just looking at those inputs and outputs, and how it now looks in EMC. So I think for us, part A is a very GCSE standard question, sketching the graph of y equals 2x plus 3 for values between -5 and 3. But now we're asking the students to find the domain and find the range. If you have Active Hub as well, the textbook is interactive as the other teaching textbooks as well. So you can show these on your screens as you work through and show solutions. I've just taken some screenshots for the textbook, so you can see that it's really broken down into work solutions. Remember, the concept of this course is there shouldn't be any additional teaching required. We are leaning heavily on independent study. which is the directive through the writers, the writers of the textbook, made sure that there was a lot of steps, a lot of notes, so you can, leave students to work, lunch clubs after school independently. So you can see here sketching the graph. So part A, the values, the Y values for the minimum and maximum. And then there's a nice graph sketched out, reminding the students to label the intercepts and the coordinates of the endpoints. So let's talk about that domain then for part B. So we're identifying these X values, we're identifying the points, so reminding the students that the domain is those inputs. So we know that the X values have to go from -5 to 3. So using those inequality notation that they've got from GCSE, but now adding in that notation that X is a set belonging to R, the real numbers. So we're using their curly brackets as well. And then part C, is finding the range. So we're looking at the function that produces as it comes out. So we've identified the minimum and the maximum X values. So there we go with the set notation at the bottom. The function of X is the set that belongs to the real numbers such that we have -7 and up to 9. So identifying that they are the range of numbers included in this function. So I think you can feel where the little extra bit comes from, the deeper understanding. Anything that is brand new, such as the notation, I think that the textbook itself is a fantastic facilitator for students to understand that, and should require real minimal input from teachers. Let's have a look at another one. So here's the graph of f of x is 1 over x minus 2, given us the graph, and it says to find the domain and the range. So obviously we can see x equals 2 as an asymptote. So students should know through their GCSE study that x cannot take the value of 2 because we can't divide by 0, it's undefined. And so the domain is all real numbers, but x cannot equal 2. So the notation there, practicing that accurate notation. For the range, the function of x being 0 is an asymptote. Obviously, the function of x can't take the value of 0. So the range is the function of x such that belonging to real numbers. And so the function of x cannot equal 0 for the range. So I've picked out some example questions, and within the team we've also talked about, as we move through the delivery of this course through this year and getting ready for those teachers that will be first teaching next year, and experienced teachers like some of you guys going into your second year, we obviously like more practice. So I found a couple of examples here. Remember, we have the sample assessment materials, we have our first set of specimen papers, and there's a whole bunch of topic tests that are on the Maths Emporium as well. I've picked out a couple of examples on where we might see domains, ranges, and that set notation, and thought I'd share them with you, so you get an idea, and then we'll move into getting a real deep dive into linear programming. So question 1 that you can see on the top right, this is from the topic tests. So you'll see there's a whole bunch of topic tests in that folder. And this one comes from functions and inverse functions. So question 1, we've got a function of x being 2x squared minus 1, and a function g of x being 5 over x plus 2, and the students being asked to write down the range of the function of x. And then they're writing down one value that should be excluded from the domain of g of x. So I've taken a snippet out of the mark scheme. Of course, we're looking for numbers x greater than or equal to -1 for the range for f of x. And of course, we can't have the denominator, get my right words, the denominator being 0, because that's undefined. So the value being excluded from the domain of g of x will be x being -2. The bottom one, I think you can feel that we are used to representing inequalities on number lines at GCSE, but now we're asking students to just have a look at that set notation. We've got t values being less than or equal to -1, union t greater than 3, so could use or if you like, making sure they're colouring in their dots where appropriate. So you can see this nice little number line here, which will help students to see where they should look. Of course, they might want to write them down, but of course, question asking them to represent it on the line. So hopefully that's okay for domain and range. I know it's kind of small topics, small marks available, but I think it's a real good setup for students as they start to work with sets as they go into A-level. Before I take a dive further into linear programming, I'm just going to go back and show you the spec references for linear programming. So as before, we've got GCSE, so we're asking students to solve linear equalities, one variable, and represent them on a number line at GCSE. And then when we get to A-level, they're being asked to solve linear inequalities in one or two variables, quadratic in one variable, and represent solutions on number lines using set notation and on graphs. And then we have the EMC, so solving linear and quadratic inequalities as a single variable. We've got, sorry, this is A-level, by the way, the previous one's EMC. So solving linear and quadratic inequalities in a single variable and interpret such inequalities graphically, including inequalities with brackets and fractions. Of course, this is A-level, got my two boxes around the wrong way, and express solutions through correct use of and or. So we've just had a look at that in that previous example for EMC. So it's just nudging students a little bit deeper and getting them ready for that. So just to clarify, we're going from solving linear equalities of one variable and representing on a number line at GCSE, then going into EMC, where we could do that with one or two variables with quadratic inequalities and representing solutions on number lines, and starting to use that set notation and representing graphically. So that's the step between, and then the step up into solving linear and quadratic inequalities, single variables and inequalities graphically, then using them with brackets and fractions, then going into solutions being expressed using correct notation, correct set notation, and then being able to represent linear and quadratic inequalities graphically. So big jumps. If you looked at the GCSE to the A-level, of course, there's a huge jump in there, which is why it's really important, or we feel it's really important that students have the opportunity to study a course like extended maths, so that jump doesn't feel so stark. So let's have a look then. So we've had a lot of teachers talk to us about linear programming, feeling a little bit anxious, shall I say, about it, a little nervous, not done it before. So hopefully we can have a look at where the GCSE course sits and how we can transfer and transition into real life context. So if we look into the GCSE higher book, if you've got the kind of version 2, this is book 2, it's chapter 15.2 if you have it, but you know, it's, as always, you don't have to be using these textbooks to be able to deliver this content, but we've seen examples like this. So we've got a coordinate grid, we've got a grid, and we need to shade the region that satisfies all of the inequalities. So this is representing inequalities on a grid. So we've got x is less than 5, which you can see by the dotty line on the right hand side. Y is less than or equal to 2x plus 4, which is the red line. Y is less than or equal to 1, which is the green line. And then y is greater than -2, which is the horizontal dotty line. And of course, everything that's bound between those we can shade in, reminding students that a solid line for an equal to and a dotty line for greater than or less than. So that's what we're used to. That's, you know, we've also asked students to identify points that satisfy all of those inequalities. And you can see a test point at the bottom, 2, -1. So that's what we're used to at GCSE, and students should be comfortable doing that. Here are some questions that they may have seen at GCSE. So the one on the left and right, both interpreting them, but the one on the left, a little bit more of a real life element. So I say real life, they've just said that this is her maths homework. So for her maths homework, Helen's answered the following question. She shades the region that's identified. She's made some mistakes, write down 2 mistakes that she's made. So, you know, students reasoning there. And then for the question on the right, write down 3 inequalities that define the shaded region. So using their straight line graph work, gradients and intercepts to be able to identify that region. So when we look at EMC, we start to think about linear programming being real life functions that we can use our inequalities to represent situations in real life and find those regions that satisfy, that can help us solve these real world problems. So the question on the left is, I'm going to come back to these a bit later, so I thought we'd just pick up on them a bit more so you can have them in the back of your mind when we talk about the key points that students need to be aware of. So Savio is buying base cupboards for a catering kitchen. The cupboards come in 2 sizes. We all know this if we've done a kitchen refurb. So we've got 600 millimeters wide and 900 millimeters wide. So we're defining X to be the number of 600 millimeter cupboards and Y is the number of 900 millimeter cupboards. The 2 constraints are X is greater than 2 and Y is between 0 and 9, including 9. Explain in context what 0 to 9 means, what that inequality means. And then at the bottom, we've got some costings. So the 600 cupboard costs £210 and the 900 cupboard costs £240. There's a budget in place. The total width of all the cupboards is 12 meters or less. And then we're using all of that information to show those sets of equations given there. Then it takes the students further to represent these graphically. We're drawing on a line or, you know, draw a line on the grid and identify the feasible region. So we're asking for the additional lines. Savio decides to buy 7 of the 600 millimeter cupboards and the maximum number of 900 millimeter cupboards. So we're starting to use that wording. We've got exactly 7, a maximum number of 900. So we know we've got to be less than that maximum number. So we need to work out the total amount of money that Savio is going to spend. Okay, let's have a look at some key notes for students then. When we're using inequalities to represent real life problems, that is all that linear programming is. There's no computer task, there's no, you know, understanding formula within you know, IT at the moment. I mean, who knows what math study will look like in the future. And then, of course, we talk about the feasible region, and that's the region of points that can satisfy all of those inequalities. So when you're delivering this to students, maybe in your lunchtime clubs or after school, or you know, whether you've got a group of students that are in the separate table, for example, please reassure them that it's nothing further than inequalities on a grid, but we've got some real life context involved. In the textbook, they've got a really nice example using mugs and bowls. We've got Shona and Shante making bowls to sell. Shona's making mugs, for example. So it's a nice similar example to what we've seen with the kitchen cupboards. So Shona can make up to 40 mugs a week and Shante can make up to 30 bowls a week, X being the number of mugs and Y being the number of bowls. And writing down 2 inequalities that can represent the information. So we know that the minimum they can make is none. So a maximum of 40 mugs for Shona and a maximum of 30 bowls for Shante. And there's a little note on the side so students can see why that is. And then it goes on to ask, well, in any one week, this inequality is also true for X plus Y being greater than 45. So we want the number of mugs and bowls to be greater than 45. So describe in context what that means. And there we have it. They make more than a total of those items each week. So it's understanding and reasoning there. And then they have to go off and by drawing their suitable lines, they're going to show the feasible region for those values of X and Y. So they've been given a maximum of X, maximum of mugs and a maximum of bowls. and then their x plus y equals 45, and they have this nice little graph that they can represent. We've got a dashed line, remind them, for that third inequality, and then shading, because we want to say showing the feasible region. It might help them to shade outside, exclude outside, so then they can identify the feasible region of what they can have. So here we go. The vertices, so they can have a look at each corner. Of course, we can't have half mugs or half bowls. That's always a point that comes up from examiners, isn't it? Making sure that students' solutions are appropriate or sensible. So the example 2 is taken from that kind of previous context. So using the objective function p equals 5x plus 7y and the feasible region from the previous graph, they need to work out the maximum profit that they can make in a week. And so, identifying those critical points. So the vertices of the feasible region are 1530, 45 and 4030. So you can identify those by those the x's on the graph, and then it's a substitution into the objective function given in the example. So we can see the first one gives us £285, the next one gives us £235, and the last one gives us £410. And so the maximum profit they can make in 1 week is 410. And that's because they make 40 mugs and 30 bowls. Here's an example of a question from the SAMs and specimen papers. So what's it going to look like in the exam? Is questions that we get from the teachers. How's it going to look? Have you got some practice questions? Obviously, with the first series coming this summer, we'll start to build that bank of past questions, and we'll do everything that we can in the team to help chop up those papers into manageable chunks to help your students practice for the following year. But this is part of a question that I picked out to show you what it will look like. This one here, it's not got the context attached to part C, just asking the student on the grid, show by shading the region defined by the inequalities. So we've got 2y minus 5x is less than 10, and then y is greater than 3x, all multiplied by x minus 2, and they need to label that region. So I've got the solution here. We've got work solutions for questions on the website, also got them on the Maths Emporium. So just denoted in different colours, we've got the working out for the left-hand inequality in blue and the right-hand one in green. So we've got a nice curve. Students expand that bracket. They know how to use their values, obviously not a table of values, but they can create their own table if they need to. Substitute in kind of those inputs and outputs, domains and ranges, talk to them about that, keep those keywords still going. And then they plot and get a beautiful parabola and a nice straight line, and then they end up with their region, which they can shade. And then the bottom part D at the bottom of the screen there says write down all of the integer pairs that satisfy those two. So of course we can then start to make crosses on the grid. We can find out where they're working, and so you can see the pairs are coming on the side in the green, so they're all the feasible pairs. Let's go back to the cupboards then. So Savio's base cupboard. So we know that the constraints that have been put in place, x plus 2 and then 0 to 9, explain in what context that inequality represents. So here we said the number of 900mm units is greater than 0 but less than or equal to 9. So it's just being able to communicate that they understand what that means. Then we had to work out the total, with the total width of the cupboards being 12 meters or less, and the fact that he's got a maximum budget. Can we use that to define these inequalities given? So it's almost a prove that, or as defined here, a show that question. So it's setting them up. We've got the cost. So we know that the 600mm cupboards are 210, represented with a variable of X, and then we have the 900mm cupboards at 240, variable Y. So the cost is 210X plus 240Y has to be less than or equal to 360, because we have divided by 10. We divide that back through by 30, and then we've got 7x plus 8y is less than or equal to 120. So the cost is defined. We've got the size given as well. So we know that 600x and 900y has to be less than or equal to 1200. We've changed that into we've converted our 12 meters. We're going to divide all that through by 300, and we end up with 2x plus 3y is less than or equal to 40. And then that is exactly what the question has asked for. Then we have to draw this on the grid. So draw a line on the grid and identify the feasible region. So we label the feasible region. We've got nice little arrows. I used to teach my students to use the arrows to just almost point to where they're allowed to go. So we've got a nice feasible region in this, I want to say trapezium, but at close inspection it's not. But in this little section here. And then we have that bottom question where he decides to buy 7 of the cupboards, the 600mm cupboards, and then there's a maximum number of 900mm cupboards possible. And we want to work out the total amount of money that Savio is going to spend buying the cupboards. We know we're allowed 7 lots of 210, getting that information from the previous part, and then 8 lots of 240 is £3,390. You can use the graph from before. So yeah, total of 3,390. So I'm going to go through the resources. It's really important as you're in the thick now, thick of the delivery, thick of the academic year, that you know exactly where to go for all of the resources. So I've mentioned the textbook. My screen is all fuzzy, so I won't lift it up, but textbook, really student friendly, great, even if you have teachers in your department, early career teachers, non-specialist teachers. As you can see from the screenshot there, so many notes, kind of step-by-step worked solutions for those examples. There are hints and talking points. I know it's only a screenshot, but in the top left and the bottom right corner there, you can see talking points. The top one at the left, this chapter is chapter 1 number, and is specifically looking at surds. And it, you know, the talking point, why are square roots of square numbers, why is root 4 and root 5 not, you know, why are they not a surd, for example? So it gets them to talk about interesting maths concepts. There is so much practice, which was something we heard from teachers. We just need lots of practice for every lesson. So you can see on the right-hand side, after they've looked at manipulating those surds, there's a lot of practice for them to get their teeth stuck into. There's hints in case they're getting stuck. There's exam style questions, and the examiners that are writing the exam papers have also fed into and written the textbook as well. So you know, we've got great confidence that the people writing the textbook are the people writing your examination questions as well. There's a mixed practice chapter as well, so it really does shuffle everything up and give those students a really good sense of the end of the chapter, a bit of everything. Problem solving and reasoning questions, so they can really apply that mastery element into what they've learned. And there are clear GCSE signposts, so they can see exactly where the links are from their previous or current learning, because this is a course that's designed to be taught alongside GCSE. And I know I'd be doing the same, kind of delivering my GCSE content and allowing my EMC students to just dig a little bit deeper into some of the practice questions. Brand new merchandise is out. I've got a fuzzy screen, but water bottles, notebooks, coffee cups. They were trending on Twitter last week. put yourself in the chat, or come and drop me a message on Twitter. It's at Miss Maths Geek on Twitter. Let me know. I'm going to pick out some people. There's only 50 of each of them, but if you'd like to get your hands on some of the merchandise, I'm going to pick out some lucky people to get their hands on those, so please let me know. There's QR codes on the back of the merchandise as well, so it'll take you to websites where you can get extra support, and the notebook's got handy little pen holders. You put a pen in the side as well, so let me know if you're interested in those. Drop me a message. I mentioned Active Hub. You get that interactive book. There are video walkthroughs. I'll talk about those as well in a second. Fully worked solutions. They're in PDF. They're great for students to have independently. There are editable worksheets. I've mentioned the SAMs. You can zoom in and zoom out. You can hide the answers, reveal the answers if you're in a school where students are working in an IT room and you're giving them the access, or iPads, etc. They can use that functionality. And all of the published resources that we've done so far. So the website, the link, all of these links are hyperlinked in. So when you've got the slides, you can click on them. So the website itself has got everything we've mentioned. The textbook link is there. It's around £30. The Active Hub, I'll put some contact details up in a second. So if you want information about Active Hub and how to have that front of class kind of interactive learning, then do let us know. And as I mentioned, there is a whole world of sharing good practice out there. Corbett Maths, BBC Bite Size is the one that students like to use. But you know as well as I do, there are so many great golden nuggets of different resources. But there's a couple of links there if you want to help build upon that GCSE practice at the moment. Linear inequalities and functions. Be careful not to take them too far into A level. We don't want them kind of, no spoilers, and we don't want we don't want them to pick up anything that they don't quite understand, or inhibit misconceptions that have to be unpicked later. So just be mindful not to take them too far. And there's a little QR code down at the bottom where you can see that sample chapter. If you've not yet had a look at the textbook, it will take you straight through to that sample one. So the more support, so of course the Maths Emporium has all of the cabinets. We have our own cabinet for the extended maths certificate, and in there there are schemes of work. So if you haven't used or taken a look at these, we've got a 1-year scheme of work which includes all of those mappings. If you're delivering international GCSE, it will map there. Obviously some of you guys will be teaching A level as well, so you can, if you're not actually teaching EMC this year but you are teaching A level, you can kind of see where it feeds in. So if you're going to pick up delivering this course next year, it will make more sense as to what those students will be picking up ahead of A level. There's also a 2-year GCSE maths scheme of work, and we've put the EMC notes in there so you can see where you're delivering your GCSE content. There's some additional guidance on where you can integrate the EMC delivery. So if you are doing them side by side, that's the scheme of work that you want to have a look at. Lots of guidance on how to use the SAMS questions and spec points, and lots of little links into resources. So it's an absolute game changer to have that resource to hand. The topic papers that I mentioned, there are 15 topic papers now. So I used the composite and inverse function example earlier, but through all of the topics, we looked at equations of circles and area under a curve in session 1. So there are 2 sets of papers there for students to have a go at. There's a QR code at the front of these papers where the students can go to a video of walkthrough guidance from one of the writers. So a little example, and they show how to attack those questions. So again, really embedding that independent learning and the minimal input from you guys as teachers. As I mentioned, as part of the domain and range, we will be adding to these topics, probably looking at the outcomes from the summer and seeing where we can add in, where we can fill gaps to help support for the next year's delivery. That's what they look like. So the topic papers, QR codes at the front, and a tiny little video. They're less than 5 minutes, where a nice walkthrough, and there's a link in there for those. The SAMS exemplars, so we've taken some kind of that exemplar approach for the sample assessment materials, and the chair of examiners has taken our work solutions and has annotated them with where the marks would be allocated to give guidance as to how to apply the mark scheme. It's in a new format. We've done it now as a PowerPoint, so it's nice and easy as part of staff CPD. You can use it in the classroom with the students. You can print out the slides if that's, you want to give them some marking training or where to make sure they get their marks. And we're going to be producing them for the new specimen papers that came out a couple of weeks ago. So we're trying to think of everything we can to give you extra resources and extra practice. We've got a timeline of releases. So again, this is on the Emporium. We've got a little hyperlink here. The additional SAMs, or abbreviated here as ADSAMs, are the specimen papers. So we didn't want to get SAMs confused with additional, and then we've got more practice ones coming out. So we decided to keep the original sample assessment materials labelled as that, and then any other practice papers coming out will be called specimen papers, and we're hoping to have specimen papers set 2 produced next year, and as much as we can to keep you guys in check and in stock of lots of practice. So, as mentioned, contact details. Vicky Wood, our incredible subject advisor, will help no end. She loves this course as much as I do, as much as all of us do. Her email address, if you've got anything you want to ask her, or it comes through to all of us, is teachingmaths@pearson.com. Vicky as well works tirelessly at the month ahead, and puts together all of the need to knows. What training is coming up, what resources are coming out. She puts them all in a monthly and a newsletter or update, and she'll email that out. If you're not signed up to get that from her, click on that link there. It's also at the top of the Maths Emporium page, so please sign up, and it's almost like a must know list for the month ahead. And then me, if you want to get hold of me, you can use that same email address and just say, this is for Nicola. Or as I mentioned, you can send me a message. I get messages every day on Twitter or on LinkedIn at Miss_Mathsgeek. Even if it's I can't find that topic test that you mentioned the other day, can you send me the link? Absolutely more than happy to do that. We're just releasing some podcasts. If you'd like to listen to the developer talk about the development of the qualification, there's episodes. There are about 32 episodes of the right angle. There are post-16 episodes. There are episodes you can share with your children, students and children in classes about how to inspire them, particularly one with Katie King, who some of you may know is Carol Vorderman's daughter, but she used to be a science and maths teacher, and she, her aspirations are somewhat incredible, and will be really good for your students to listen to as well. You may or may not have got to this session via the Professional Development Academy or the PD Academy. You might hear it referenced to. It's ideal to bookmark this link. It's got all of the training events that's coming up. You just filter under maths, of course. So bookmark that, and it will show you exactly what's coming up. But other than that, if you're off and you're going to enjoy the rest of your evening, I just want to say thank you very much for your engagement and your attendance this afternoon. And we hope to see you at the next one.